Hey everybody, let's look at solving right triangles. This will involve finding the measure of all three angles and the lengths of all three sides. A lot of times you'll be given two of the three angles or two of the three sides, but it'll be up to you to come up with the rest of it. Now, let's also note that angles will be given with capital letters at the vertices. Their opposing sides will be lowercase of the same letter. For example, angle B, opposite of it would be side B. In this diagram, you are given angle A, side B, and angle C, because of that little square, that's 90 degrees. Now, if you're given two angles, I recommend finding the third angle right off the bat. That has to be the angle that makes all three sum up to 180. Well, since A, B, and C have to add up to 180, angle B is going to have to be equal to 180 minus the 90 degree block here minus the 34.2 degrees given. That result is 55.8 degrees. Now, I didn't label it on here because I wanted you to see the information given and what was left to find. We found angle B. Now that we know all three angles, those are done. Now it's coming up with side A and hypotenuse C. Well, make sure that when you set up a trig ratio that you know one of the two parts of the ratio and one can be unknown. That's fine. For example, tangent of 34.2 degrees has to be equal to A over 19.4, opposite over adjacent. Excuse me. Solving for A, we multiply both sides by 19.4. So side A is 19.4 times tangent of 34.2 degrees. Make sure your calculator is in degree mode. Once it is, hit enter. 13.2 is the approximate length of side A. Now at this point, you could use Pythagorean theorem to get the hypotenuse. For extra practice, I'm just going to use the information given and set up another trig ratio. I know that cosine of this angle is the adjacent length over the hypotenuse. Cosine of 34.2 has to be equal to 19.4 over C. Multiply both sides by C and then divide by cosine of 34.2, and that'll give you the hypotenuse length C is 19.4 divided by cosine of 34.2 degrees, and that's approximately 23.5 in length. In this one, we're given side A and side C, which is the hypotenuse. A and C are given. We're only missing one side. Let's go after that. From Pythagorean theorem, we know A squared plus B squared is equal to C squared. Plug in what you know. 25 squared plus B squared equals 35 squared. 625 plus B squared equals 1225. Subtract 625 from both sides, that'll equal 600. To get B, you take the square root of 600, which is about 24.5. Now we know all three sides. Because we were initially given A and C, which are opposite and hypotenuse from angle A, I'm going to go ahead and set up a sine ratio. I know that sine of A is going to be equal to A over C. I happen to know both A and C, so I can plug in 25 and 35. And remember, if you need an angle, you invert your trig. So A is sine inverse of 25 over 35. Again, make sure you're in degree mode and you get a little more than 45.5 degrees. Once you have that angle and you know this one's 90, then angle B has to be the difference between those and 180. So if you take 180 degrees, subtract the angle you just found, minus angle C because it's a right triangle, you get 44.42 degrees, and that's angle B. Once you know all three sides and all three angles, you have solved the triangle. Some applications. The height of one mountain is 5,000 feet. The distance between its peak and that of an adjacent mountain is 25,000 feet. The angle of elevation between the two peaks is 27 degrees. What is the height of the adjacent mountain? So mountain A is 5,000 feet tall. We're supposed to find the height of mountain B. Now, because this is 5,000 feet, if we go horizontal into the next mountain and then up to the peak, I know opposite of that is side B, opposite of angle A is side A. The angle of elevation is 27 degrees, and this hypotenuse is 25,000 feet. That's the different distance between the peaks. Okay, so let's survey what we have and what we need to find. I know that this part is 5,000 feet, so if I can find A, I can add 5,000 to it, and I've got the height of mountain B. Well, to get A, given the hypotenuse, I can use sine of 27 degrees because that's going to be equal to A over 25,000. Set that ratio up, multiply both sides by 25,000. 25,000 times sine 27 is approximately 11,350 feet. Don't forget to add in the 5,000 feet from mountain A to get a total height of 16,350 feet. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees, whereas the angle of elevation to the top is 53 degrees. Find the height of the smokestack. Okay, so it's a very rudimentary drawing. This is the building. This is the smokestack. At a point 200 feet away from the base, the angle of elevation to the bottom of the smokestack was 35 degrees. So that little angle here is 35 degrees, and that reaches the bottom of the smokestack. The angle of elevation 53 degrees gets us to the top of the smokestack. If we can find A and X, then we will know the height of the smokestack. X will be the height of the smokestack. First, let's look at this little triangle, and I've got a little 1 here to denote it. This little right triangle here. Sine, no, not sine. From 35, A is opposite, 200 is adjacent. So what trig ratio is opposite over adjacent? That's right, tangent. Tangent of 35 degrees is equal to A over 200. Multiply both sides by 200. A is 200 times tan 35. It's appropriate if you round that off. I'm going to leave it whole. If you do decide to round off here, I recommend saving 4 to 5 decimal places. That way you're accurate at the end. The big triangle, the outer one, I've marked it with a 2 for the big one overall. Same thing, but let's use tangent of 53. Tangent is opposite, which is x plus a, over adjacent, which is still 200, x plus a over 200. Multiply both sides by 200, x plus a equals 200 tan 53. Now, since we are looking for the height of the smokestack, all we need is x. Now, if we solve this for x, we bring a over and subtract it. So x, solve for x, that's going to be 200 tan 53 minus a. We've solved for a up here. That can be replaced with 200 tan 35. If you use your calculator, you don't have to do this third step. I just put that in there just for extra measure, but you can actually just enter this into your calculator and get 125.4 feet. So solved for x, that's the height of the smokestack alone. I hope this video helps. Please reach out by email, phone, or office hours if you have questions, and I'll do my best to help.